Hello students, this is your open course class Electronic Communication. I am Davis Johnny from the Department of Electronics, DB College, Kirur. Open course Electronic Communication is designed for students from other departments such as Commerce, Tourism or Malayalam. This course is very easy to learn and understand because it begins from the basic concepts of electronic communication. This class through an electronic medium reveals its importance. So now we start from the first chapter, Introduction to Communication. Our first chapter is Introduction to Communication. The contents are: what is communication, use of communication, structure and type of communication, communication system and data communication, communication channel, electromagnetic wave, electromagnetic spectrum, the bandwidth and channel capacity. Now we try to define communication. When we talk to other people, it is the best method of communication. This online class is another example of communication. Thus, communication is the process of exchange of information. In earlier centuries, that is before the invention of modern communication systems, people use fire, smoke, pigeon or even drums to send message to other people far away. The history of telecommunication begins with the invention of telegraph by Samuel Morse from US in the year 1837. He introduced the Morse code for short message transmission. In this Morse code, he proposed different combinations of dot and dashes to represent each letter in the alphabet or a number. In India, we used this method over 160 years up to middle of July 2013. The next major milestone in the history of telecommunication was the introduction of telephone system. As you know, it was invented by Alexander Graham Bell in 1876 in US. Tele means far away and phone means sound. This figure shows the basic structure of a communication system. It has a transmitter, a receiver and a medium in between. The transmitter is used to transmit the signal or message, that is, it originates the signal. The receiver receives the transmitted signal after it travels through the medium. The medium acts as the link or channel between transmitter and receiver. Thus, medium guides the signal from the transmitter to the receiver. Popular forms of information include text messages, pictures, audio or video, etc. Sender is the device which sends the data messages. It can be a computer, a person, a telephone handset, etc. Receiver is the device which receives the data message. Transmission medium is the physical path by which message travels from sender to the receiver. Examples include twisted pair, coaxial cable, radio waves, microwaves, etc. Every communication system is generally divided into three categories. They are simplex system, half duplex system and duplex or full duplex system. Figure shows the structure of a simplex communication system. In a simplex system, message can be sent in one direction only, that is from one end to the other, that is from the transmitter end to the receiver end. There is only one transmitter and one receiver. An example of simplest communication system is a cable TV system. Another example is a public address system using a megaphone. In this half duplex system, each end can transmit, but only one at a time. That is, if one party is transmitting, the other must receive. This system is actually introduced in order to save the cost. A single link is shared between two parties to fulfill two-way communication. Police walkie-talkie is an example of half duplex system. The third category is full duplex or duplex system. In this full duplex system, both parties can transmit data simultaneously. That is, it is a true two-way communication system. In this full duplex system, the channel is capable of transmitting in both directions at the same time. Nowadays, most of the communication systems are full duplex. Telephone conversation is the best example of full duplex system. In a telephone conversation, people can talk and listen simultaneously. Now, we are going to consider data communication. Data is the information or message in digital format. The figure shows the comparison between an analog signal and digital or binary signal. Figure A shows an analog signal. An analog signal can have any value within the range. Figure B shows a 4-level discrete or digital signal. Figure C shows a pure binary signal which have only one of the two allowed values, 0 or 1, or high or low. Thus, data communication is defined as the transfer of information using digital signals. This picture shows the best example of a telecommunication system. Here, a television channel is broadcasting its program to viewers through a satellite network. Dish antennas are used as earth stations for uplink or downlink signals. Communication channel. Communication channel is the medium between a transmitter and a receiver. So, it is the connection between transmitter and receiver which data can be transmitted. Communication channel is also called communication media, transmission media, or the link between the transmitter and the receiver. Communication channel is generally divided into two categories. They are guided media and unguided media. Guided media include cables such as twisted pair, coaxial cable, or advanced optical fiber systems are the examples of guided medias. Unguided media's examples are that is generally wireless mode of communication, microwave communication, satellite microwave communication, and radio signals for broadcasting. Usually in wireless communication system such as a satellite system, electromagnetic waves used as the energy carriers or information carriers for transmission. An electromagnetic wave is a transverse wave because its electric field, magnetic field, and direction of propagation are mutually perpendicular. Light is an example of electromagnetic wave or EM wave, traveling with a speed of 3 × 10⁸ meters per second, or roughly 3 lakhs kilometers per second. Electromagnetic waves are widely used in satellite communication, radio waves, and microwave communication. Now we study about frequency and wavelength. First, we try to define frequency. Frequency is number of cycles per unit time, that is number of cycles per second. And the figure shows the structure of a wave which shows wavelength lambda. Wavelength is the distance between two consecutive crests or peaks, that is f is equal to c by lambda, where f is equal to frequency, c is the speed of light, that is 3 × 10⁸ meter per second, and lambda is the wavelength. Now we discuss about bandwidth. Bandwidth of a signal is the difference between the highest and the lowest frequency, that is a range of frequency. For AM radio transmission, we use 540 kHz to 1600 kHz range for 106 possible channels. A 10 kHz band is allocated for each AM channels. But in the case of FM transmission, that is FM radio transmission, we use 88 MHz to 108 MHz range. 200 kilohertz band is allocated for each channels. So we can accommodate 100 FM channels. The figure shows various bands allocated for radio channels, VHF television channels, FM radio and microwaves. Now we consider another important factor that badly affect the communication system, that is noise. Noise or attenuation is the loss of signal strength as it travels through the media. Noise is defined as the unwanted signal that is superimposed on the desired signal. So, signal must be amplified or regenerated to ensure that data is transmitted correctly. Noise can affect data signal due to electromagnetic interference, radio frequency interference are usually affect desired signal. Amplifiers and regenerative repeaters are used to increase the data rate or which is used to reduce noise. So by using amplifiers or regenerative repeaters, we can increase the distance between transmitter and receiver. The figure shows a digital signal, an ideal signal and an attenuated signal plus noise affected on that signal. This figure shows an electromagnetic spectrum and wavelength is given from nanometers to several kilometers range. According to the frequency, the waves are divided into gamma rays, X-rays and UV radiation or ultraviolet radiation, then visible light, then infrared radiation, then microwaves and radio waves. This is a broad spectrum of electromagnetic wave. This figure shows various frequency bands with their range. There are several band names are allocated for each range. First is very low frequency or BLF. The range is 3 to 30 kilohertz. Then low frequency or LF. The range is 30 to 300 kilohertz. Then medium frequency MF. Its range is 300 to 3000 kilohertz. High frequency HF 3 to 30 megahertz. Very high frequency VHF 30 to 300 megahertz. Ultra high frequency UHF 300 to 3000 megahertz. Super high frequency SHF 3 to 30 gigahertz. Extremely high frequency EHF 30 to 300 gigahertz. And terahertz range is also there, that is 300 to 3000 gigahertz. That is extremely high. The next topic is Shannon's theorem or Shannon capacity formula. According to this theorem, the channel capacity or data rate is directly proportional to its signal to noise ratio. The signal to noise ratio is the ratio between signal power to noise power. The maximum channel capacity C in bits per second equal to bandwidth into log of 1 plus S by N. Thus, when noise power increases, data rate decreases. This is the textbook we follow, that is Data Communication by William Schuber, and this is the end of our first module. Thank you.